Okay, quick recap. This table will be on your exam just like this. So make sure you pay attention to if the formula has a cosine theta in it, then the graph is going to be symmetric about the polar axis. And if it has a sine theta in it, that graph is going to be symmetric about the line theta equals pi over 2. And make sure you notice whether it's a plus or a minus, and that tells you which direction you go from the pole to get to the directrix line. So let's look at this number 18, and I see I have r equals 12 over 4 plus 8 sine theta. So you can see that this is type C, because I have a sine theta and I have a plus. But I don't have the 1 that I need in the lower left. So I need to do some algebra here and multiply the top and the bottom by 1/4. So then I'm going to have 3 over 1 plus 2 sine theta. Now it's in the proper form to be able to identify the e and the p. So the product of e and p is the numerator, 3. And then we look down here between the plus and the sine theta to find the e. So e is 2. Then we're going to substitute that in to the formula for EP to solve for the P. And now we're reading on C. It says the directrix is parallel to the polar axis. So that's going to be horizontal. And it's a distance P, 3/2, above the pole. So here's the pole. Here is the directrix, parallel to the polar axis, a distance of 3/2 above the pole. Okay, so then let's plot some points. R theta, using our formula, and just a few is all you need to be able to see where the graph has to go. So if we have theta is 0, sine of 0 is 0, so we're going to get 12 over 4 or 3. So when theta is 0, this is the point 3, 0 in polar coordinates. So behind this graph is a polar concentric circles grid, not a rectangular grid. Okay, so then we're going to look at what about when theta is pi over 2? Well, then the sine is 1. So r equals 12 over 4 plus 8, or 1. So at pi over 2, you go a distance of 1 up, and you can see you're at a vertex. When the angle is pi over 2, the radius is 1, and this is a vertex. The focus is at the pole, so you know the graph is symmetric about the line theta equals pi over 2. So we've got a lot of symmetry to count on. Okay, so then if we do pi, sine of pi is 0, so you get r equals 3 again. So that's going to give you this symmetric point on the other side of the pole. So when the angle is pi, the distance away from the center is 3 in polar coordinates, remember, positive 3. Okay, and then the last point I want to plot is when theta is 3 pi over 2, then the sine is negative 1. So I'm going to get 12 over 4 minus 8, or 12 over negative 4, which is negative 3. So when I go to the angle of 3 pi over 2, then I go negative 3 through the pole, and I find the other vertex. And then you can draw the hyperbola. Okay, so the last thing we're going to look at is convert the polar equation of a conic to the rectangular version. And you might have to do some rearranging, replace r with x over cosine theta or y over sine theta. So I see I have a 8 sine theta here. So just to begin with, I'm going to try, let me do 12 over 4 plus 8. And for sine theta, I'm going to put y over r. So then I'm going to multiply both sides by the denominator and get 4 plus 8y over r times r equals 12. So I get 4r plus 8y equals 12. Okay, now we might need to do something like square both sides That often needs to happen so they don't end up with square roots, because remember, r equals square root of x squared plus y squared. So let's try squaring both sides and see what happens. So I'm going to get 4r plus 8y quantity squared equals 144. So I'm going to have 16r squared plus 32ry plus another 32ry plus 64y squared, and that's going to equal 144. Okay, so then I'm going to do 16r squared is x squared plus y squared. And then let's see, 64ry plus 64y squared equals 144. Well, that's kind of a mess. Let's see, what am I going to do about this r here that's not squared? So let me think about that one, and I'm going to come back to it, because this is not an easy one. Although, let's see, do we know what shape it is? 12 over 4 plus 8 sine theta. Oh, that's the problem we just did. So we know it's a hyperbola. And it's opening up and down. So we know it ends up being a y minus something squared minus an x minus something squared equaling 1. But I'm not seeing right now how to get there, so we'll come back to that one. So here's a puzzle problem where it says E equals 1. The directrix is parallel to the polar axis 2 units below the pole. So let's come back up to the chart. Parallel to the polar axis, P below the pole. So P is 2, and I have R equals EP over 1 minus E sine theta, because I have case D here. Okay, so I know E is 1, so I have R equals P over 1 minus sine theta, and then I know from what I'm given that P is 2. So R equals P2 over 1 minus sine theta. And this is the polar equation for our conic. And I'll come back to that problem number 30 and show you how the solution goes.